Now, as we start page 17, we're taking a look at solving and graphing inequalities now, as opposed to equations. So we'll take a look at that, and the first thing we want to do is to solve these particular inequalities. Now, for background, there's one thing we have to keep in mind, and I'll show it to you. If 2 is less than 4, that is a true statement. And if we multiply each side by 2, we then get 4 is less than 8, and that is true. But if instead of multiplying it by a positive 2, we were to multiply it by a negative 2, that is, both sides of the inequality, we're multiplying by a negative, this then becomes negative 4, and this becomes negative 8, and this no longer is a true statement. So in order to keep it true, whenever we multiply or divide by a negative, to keep our statement true, we have to reverse the direction of our inequality side. And we're going to see this here in example 1. To solve for a positive k, we're going to have to divide this side by a negative 3, and this side by a negative 3. But remember, since we are dividing by a negative, to keep this inequality true, we have to reverse the direction of our inequality sign. So this now becomes a positive k, and this becomes a positive 8. And that is the solution of this first one. Now, if we don't have to multiply by or divide by a negative, then we don't reverse the sign. That's the only difference between solving inequalities and equations. So here we're going to transpose. That's the same procedure. Just subtract 2 from both sides. Now we're going to divide both sides by 3, and we get x is less than or equal to 3. And here we have, again, try to keep your variables positive. So we're going to transpose the 5x. On this side becomes a negative 5, so this will be 2x. And here we're going to subtract 3, or transpose. On this side it becomes a negative 3, and a negative 1 gives you a negative 4. We're now going to divide by a positive 2. X is less than a negative 2. Now they did ask us to graph these, so before we go on, we'll do that. And on your worksheets, you're just going to make a number line, and we're going to put the number we're interested in. Here is 8. Here it'll be a 3, and here it'll be a negative 2. Now we have to describe what's going on here. This is k is greater than or equal to 8. So is 8 included in the system? Well, in the old days, when we had something included, we used to put like a solid dot there to indicate that 8 was included. Well, in our textbook, we use a bracket. That indicates that 8 is included. And then according to the direction of our inequality sign, the arrow goes off this way. So this is the graphical display of this inequality. Now in interval notation, which we'll be using also, we write it bracket 8 So it's starting at 8, and it's going out here to positive infinity. Infinity always has a parenthesis. Now for something like this, it's 3, and because it's less than or equal to, because of the equal to sign, we use a bracket, but this time it faces left, and then following the point of our inequality sign, it goes this way. And in interval notation, this is coming from negative infinity up to 3, and we include the bracket to indicate 3 is included in the system. And then here also a negative 2. Now this is x is less than negative 2, so 2 is not included in the system, and we used to show this by putting a hollow at 2. Now to indicate that hollow, we use a parenthesis now. That indicates that 2 is not included. Again, following the direction of our inequality sign. And in an interval notation, this would be from negative infinity up to negative 2. And we use a parenthesis here, again, to indicate that the negative 2 is not included in the set. Now, for these, you can just work along with me. We have to rewrite, get rid of the parentheses. So negative 4, 16p, distribute, plus 8, negative 8p is less than 4p minus 16. We're now going to group like terms. We have a positive 16p and a negative 8p gives us a positive 8p. We have a negative 4 and a positive 8 gives us a positive 4. And now we have it in the form we like to have it in. So I'm going to transpose the 4 to this side, subtract it from the 8, we get 4p. We're going to subtract 4 from this side. We keep our inequality sign. This is going to be a negative 20. We're going to divide both sides by 4. So p is less than negative 5. Dividing both sides by 4. Notice since we're dividing by a positive, we do not have to reverse the sign. Now a graph of this is negative 5. And we're going to use a parenthesis because it's not included in the set. Following the direction of this arrow, it goes this way. And then interval notation, it's from negative infinity to a negative 5, parenthesis. Now, in example 5, we have what is called a compound inequality. We have a variable in the center, and we want to isolate that variable. So we're going to subtract, and this is a good way to do it, subtract 11 from there, and from there. So this becomes then a negative 3 is less than 3y. This is a 0, and this is less than or equal to a positive 3. Now to solve this, we're going to divide everything by 3, so we isolate the variable. So this is a negative 1 is less than y is less than or equal to 1. Now on a graph, that would look like a negative 1 there, a 1 there. Here we would have a parenthesis going this way, and here we'd have a bracket because the 1 is included in the set. Here the negative 1 is not included, and we fill it in the middle. And you'll probably have in your math lab multiple choice to choose from, but you want to know what symbols go at the end of this. So in interval notation, this will be parenthesis negative 1, comma, 1, bracket. Now, for example 6, what we want to do is get rid of this fraction. So this is one term, this is one term, this is one term. We multiply each term by the lowest common denominator, which is 3. So here when we multiply all of this by 3, the 3's are going to cancel out. So we're just making this bigger so the fraction disappears. So we now get a negative 36 is less than 6x minus 24 is less than 12. Now to get rid of the negative 24, we're going to add its additive inverse, which is a positive 24 there, 24 there, and a positive 24 there. So we're adding the same thing to each part of our compound inequality. So this ends up being a negative 12 is less than 6x is less than 36. And again, to get rid of the numerical coefficient of the variable, we divide by it every part. Now it's critical that you show the work to get to your answer. So this now becomes a negative 2 is less than x is less than 6. So the graph, negative 2, 6, and we have parentheses in both sides. We darken the center part, and an interval notation from negative 2, comma, 6, parenthesis. Again, the parentheses indicate that the 6 and the negative 2 are not included in the set. So again, not too bad. So we had a little advanced work on this already. Here they want us to write the following inequality graph in interval notation. Well, we can take it right from the graph. So this is coming from negative infinity, and infinity always has a parenthesis, comma, and 5, 6, that'd be 5, 4, 3, negative 3, and it's a bracket there, and there it is. Now, you might say, what would be the inequality for this? Well, it would be x is less than or equal to negative 3. So this would be the graph, this would be interval notation, and this would be the inequality expression. All right, let's look at this one. So this is negative 5, negative 4, negative 3. So bracket, right from the graph, negative 3, comma, and it's going to positive infinity. And the expression of this would be x is greater or equal to negative 3. Now, another kind of method to express this sometimes is what we call set builder notation. Set builder notation is in braces and looks like this. All we do is add x is such. That vertical line is such. X is such that x is greater or equal to negative 3. X is such that x is less than or equal to negative 3. And we put that in braces. Okay, so we'll let you work on these two and see what you come up with. So right from the graph, it'll be a bracket, negative 9, and then it's going to 6 now, and 6 has a parenthesis. And here it's coming from negative infinity, going up to 5. And what do we see at 5? A parenthesis. So you might say, how would you write this in its inequality form? So it would be negative 9 is less than or equal to x is less than 6. And here it's going to be x is less than 5. And for this one, if we wanted to put it in set builder notation, just add x is such that x is that. We'll give you a chance for 5 here. Again, looking at the graph, it should be easy. Bracket, negative 3, comma, 7, parenthesis. And in its expression form, it would be negative 3 is less than or equal to x is less than 7. Okay, not too many examples, but you'll have your practice and quiz me's. Now a little quick background here is when we're dealing with cost function and we look at these two equations that are in function form, this is the cost function. That's the symbol for cost, C. And this is the symbol for R, which is revenue function. So cost is what you have to spend to make something. Well, often to make an individual product, there are certain materials needed. That's what goes here. Then you might buy machinery, which are fixed cost. That's like capital investment. That goes there. So as we look at this one, they're saying the capital investment was like $400. And to make a single unit, this type of battery, the materials just to go into that unit is 40. So this would be 40 to make one of these units, the individual material needed to make that, and then the machinery and the general cost to make something goes there, which is 400. Now, when you sell these batteries, remember it costs $40 to make one, but you're going to sell it for $50. So that's the sales price. When you sell something at the register, they pay $50 for each of these units. So they're wondering here, how many would have to be produced and sold so that the company breaks even? Now, if we looked at that in a graph, your revenue function would start at 0 and go up like so. Every time you sold, it would add. But your cost, you had to invest $400 here, and then there's other cost, and that line would look like this. It is less steep. Here the slope is 50, here the slope is 40. But there is a point where the lines intersect. At this point of intersection, that's your break-even point. So how would you solve this? Well, we said this is considered like a y, and this is considered like a y. So we have 40x plus 400 equals 50x. That is, this is a y equals a y. So we're going to solve for x now. We subtract 40 from both sides and we get 10x equals 400. And now you divide both sides by 10, and you get x equals 40. So you would have to sell 40 batteries in order to break even. Now, number 2 is very, very similar. I won't go through all the background, but basically it's 400 here, and it's 50x there. That is your cost. Equals, now you're selling things for $70, so that's going to be a better deal here. You're making more money on each sale, so as to subtract 50, and that gives you 20. X equals 400. Now divide both sides by 20, and you get x equals 20. So here, instead of having to sell 40, you sell 20 of this item to break even. And one more, 25x plus 600 equals 40x. Subtract 25 from both sides, you get 15x equals 600. Divide both sides by 15, and you get x equals 40. So 40 seems to be a lucky number here. Well, let's see if you've gotten the rhythm here. What would you do? 60x plus 600 equals 85x. Again, subtract 60 from both sides. That's going to give you 25 and 600. Divide both sides by 25, and you get 24. So to break even, you must sell this many books, 24. All right, and then finally this one, very similar, 45x plus 450 equals 70x. Subtract that from both sides, you get 25x, 450. Divide both sides by 25. And you need to sell 18 of these units in order to break even. Looking at the answers below, they want this in interval notation, all of these. So as you just take 24, and that is included in the set, and then up to infinity. And this would be 18 is your starting point of breaking even, and up to infinity. Infinity is always with a parenthesis. I see we're approaching 24 minutes, and I want to keep these between 20 and 25 minutes, so we'll pause here and pick up shortly.